Swayam Prabha. Digital India. Educated India.
Inductors, they work in exactly the same way, so I won't spend any time or a lot of time on this. Okay, then let me take the familiar one also. We know the differential equation for this VC here, okay, and here I will write it for IL. Just for the heck of it, I could write it for this voltage also, VR as well, okay. So this one we know, I am going to write it right away. This is the voltage across the capacitor, this is the voltage across the resistor, and the total equals Vs. Okay. Now in this case, what do we have? Vs minus ILR, which is the voltage across the inductor, is L times dIL by dt. Okay. So if I rearrange this, I get L by R time derivative of IL plus IL equals. And if I write it in terms of VR, there is nothing special about it. VR in this particular case is IL times R. Okay. So I will get L by R okay, I get something like that. So I will just associate the terms and explain this. This is the time constant, so that is the time constant L by R, okay, and everything else is exactly the same as in this case, okay. Now the inductor is sort of the counterpart of the capacitor with voltages and currents interchanged, right? So you cannot have a discontinuity in inductor currents if you have finite voltages, but clearly if you apply a current source directly to an inductor, you will have discontinuities, right? So similarly, you have to look for nodes where you have only inductors and current sources. In that case, if you have a step in the current source, there has to be a step in the inductor currents also, right? There is no other way KCL will be satisfied. So just like loops of capacitors and voltage sources, you have to look for nodes with only inductors and current sources, okay? So that will give you possible discontinuities in inductor currents. Otherwise, there will be no discontinuities in inductor currents, and you evaluate everything the way you did before, okay?